So for this, we're going to work with some forecast data. So this is the data set called GFS. This is a global forecast system which generates weather forecast at each pixel for the future. So the way this data set works, it is a global model. It's a simulation model that runs and it produces forecast every 6 hours. And at every 6 hours, the model will run and say, what is the forecast for the next 14 days? And as every 6 hours, there's new data that's available. So the forecast might change every 6 hours. As you get closer, you might get better forecasts and so on. So the way the data set works is you have different bands. So you can have forecast on temperature, humidity, wind, precipitation, cloud cover, and so on, right? So these are the kind of different variables that are being generated. And you have the forecast that is generated at 6-hour intervals. So right now, let's just do a weather forecast for temperature. So we select this one band and we have selected this. Now, every 6 hours, you have hundreds of images that are generated. At each time step, you say, I'm forecasting now, and I have images for all the 14 days in the future. Yeah. So let's see what the current forecast looks like. So I'm creating the date now, which is the current time, whatever current time is there. And we'll say, give me all the images that were created in last 10 hours. So let me just print the filtered one. So again, it doesn't match. I think there were no images generated in the last 10 hours because images take some 6 hours to generate, and then Earth Engine will ingest it. There might be some delay. So maybe you want to increase it a little bit. I'm going to make it 15 hours. And you can see now there are 68 images that were generated. Okay. Maybe I want to make it a little more. Let's see. For 20 hours, we have 277 images that were generated. And each image, if you look at the properties, it says the time of creation and forecast time. So what this image says, it was created at this date, and it is forecasting the temperature at the same time. So it's basically saying what is the current forecast, current temperature according to this forecast. Let's look at the next image. It was created at the same time. You can see it was created at the same time, but it's forecasting a different time. It's forecasting 1 hour in the future. Okay. So you can see now we have images which are named F001, F002. That means it was created and now it's predicting the value for every hour for next 14 days. Okay. And we want to plot that. So we want to say, give me the latest generation, latest forecast. And the latest forecast says was created at this time, and it is forecasting for future. So these are all future dates. And we want to plot that. If you plot this, the plotting functions use this timestamp. Right? You can see all the timestamps are the same. This is the timestamp is when the image was created. So if you plot this, this will all show the same timestamp. You'll not see the time series forecast. What you want to do is you want to plot this value of this image at the forecast time, not the creation time. So there are two timestamps, right? The image when it was created and image when it's forecasting. So what we want to do is we want to now update this thing. Don't use the system colon time start of this. Whatever values in the forecast time, use that as my system colon time start. So let's do this. We'll update system colon time start. So we'll take our data and we want to update every image. So we'll just map a function. Each function will get my input image, and we want to return the process version. So we'll first get the value of the forecast time. So this will be the image.select. Select allows you to, get allows you to get the property. So I'll say get the forecast time. So this is what I want to use as timestamp, so I can kind of see the image values for the future. And we'll return the image by setting the system colon time start to be the forecast time. So let's see what is the result of our processing. Same number of images. Let's look at the second image here. Here, the creation time and the timestamp are the same. Forecast time is different. In our processed version of this data, can see my system current time start is equal to the forecast time. It's not the same as the creation time. So now the value that I'm plotting will be shown as the value belonging to the future, not the one in the current. So this is just the pre-processing thing that we had to do to make sure that we forecasting the data, plotting the forecasted value. Now we have a time series of forecast. Let's plot it. We have two geometries. Right now, I'm just going to plot it at one location, and we'll see how to change that later on. So I'll create the chart, same chart that we've been using. UI.chart.image.series. So we have the image collection. It's the filtered one. Region, we'll just say geometry 1. Reducer, doesn't matter. We have a point, but let's use mean. The scale of this particular image, the pixel size is 27830. And let's print the chart. So now you can see currently we are at August 7th. This is in UTC, right? This is the time in UTC. And now we are going all the way 14 days in advance. Right? So according to this data, at this location, this will be the temperature at this hour in the future. I want to set some options just to make the chart more readable. Right, so we have this time series of temperature forecast at single location in the future. You'll notice that you have a lot more points at the beginning and fewer points at the end. The way the dataset works, it generates hourly forecast for certain hours. After that, it changes to 6 hourly forecasts. Again, you have less confidence in the values as you go forward. So you can see there are more dense images here, less dense values as you go in the future. And what will happen is now this model will run again in 6 hours. It'll generate another forecast, which will start from here, and it'll give you another chart like this. So at every 6 hours, you have 384 images for the future. That's how the data set is set up, right? And it'll keep doing this at every interval. So let's say I have 2 locations. I have geometry 2 as well. So here I have 2 points. I have one city and I have another city. So I want to know what is the forecast here. Maybe I'm planning a vacation and say which city is better to go. And I have these 2 locations and I want to compare different forecasts there. So we have one more function here. You can see there's a UI chart image series by region. Compare that with the series function. The series function takes a region, a single geometry, versus the regions, series by region, takes a feature collection. You can give a feature collection of multiple features and it'll plot the value at each of those locations. So we can use this function and then give a feature collection of all the different locations that we want to plot it. So we have 2 geometries. Let's create a feature collection. So I'm going to create a feature collection called location. I'm creating a feature collection because I just have geometries. If you have a shapefile of those and you upload this, you can just use it directly. Let's say you have a shapefile of 10 locations. Just upload that, use that directly as the variable. But we don't have that. So I'm just creating a feature collection with a list of features, right? So I have e.feature. This is geometry 1 and some property. Name property is the city. The first name is the city I'm currently at. So this is the first feature. And I have the second feature, which is the other geometry, geometry 2, which is another city in India. And so now I have a feature collection containing geometry 1, geometry 2. This is the 2 points that I have. And now I can plot this using the new chart function. So let's just try this UI.chart.image series by region. Okay, so this is the new function. So here we have the same image collection, which will be our filtered regions. Instead of giving a geometry, we just give locations. Reducer doesn't matter in this case. Band doesn't matter which band you want to plot if you have multiple bands. Scale, which is the same scale as 2730. X property, we have our system grown time start. Series property, that means you have multiple feature collection. What do you want to name each plot? Right? And we have this name. Remember, we gave name to our each point. So we'll use that as our series property. And let's print it. Yeah, you can see now I have 2 time series, right? Each one coming from a different point. So this one is the first city, this one is the second city. And you can see now the forecast at different cities. And let me just set the options. Again, you can set the series color correctly, and you can see now I have this nice chart having the forecast at these 2 locations. Here we're using the legend position top, so you can see the legend appears at the top here.